All right, welcome everybody to tonight's dialogue on why you should care about soil with Dr. Cinzia Fissore. I'm going to start off with a few quick announcements from Sustainable Claremont and then hand it over to our speaker. First thing I want to make sure you're all aware of is that Sustainable Claremont's third annual Green Home Tour is coming up. Right now, we are looking for homes to feature at that event. And if you think you might be interested, please contact Han, our outreach coordinator. She's going to put her email in the chat box for us. The other next announcement I want to make is that we have another dialogue coming up a week from today. Jeff Hanlon is going to be talking to us about water policy, and that'll be using the same link as this evening's meeting. We'll also be putting a link into the comments about how you can order Sustainable Claremont swag. We have t-shirts and other items you can order with the Sustainable Claremont logo on them, so please keep an eye out for those. And then the last announcement I want to make is to share a little bit about the Energy Upgrade California program that Sustainable Claremont is part of. This is the Power Saver Rewards and Flex Alert program. And the way this works is that you get bill credits on your power bill if you reduce energy use during a flex alert. So flex alerts come out when there's an expectation of high power usage between 4 o'clock and 9 o'clock p.m. You can sign up and reduce your power usage during those times. And that ends up being helpful because power outages can disrupt lives and really harm vulnerable people and communities. There's no penalty in this program if you don't reduce your energy usage, and there's no penalty for not signing up. And millions of people have already signed up and are earning bill credits for participating in this program. The way it works if you're signed up is that sometime before that 4 o'clock window, you pre-cool your home, do anything you need to do using major appliances, you cover up your windows and make sure your electronics are charged. And then during that 4 to 9 window, you delay using any major appliances like doing laundry or running the dishwasher. You set your thermostat up to 78 degrees or higher, turn off any unused lights, and unplug any unused devices. You can sign up for Power Saver Rewards by visiting the Energy Upgrade California website. And again, there's a link for that Han will put into the chat for us. With that, I'd like to introduce our speaker. Dr. Fissore is an associate professor of biology and environmental science at Whittier College with over 15 years of research experience in the field of soil science and biogeochemistry across ecosystems, from forest to urban ecosystems to agricultural systems. Dr. Fissore's research investigates soil organic carbon cycling and stabilization associated with different environmental conditions and in response to climate change and anthropogenic impact. With that, I am pleased to be able to hand things over. Give me just a minute while I make sure that Dr. Fissore has the permissions that she needs to be able to share. Where did she go on here? There she is. All right, Dr. Fissore, you are now the host of this meeting, so you should be able to unmute yourself and share your screen, anything else you need for making your presentation.
Thank you so much. Thank you for the introduction. And it's such a pleasure to be part of this group. And I'm really excited that you'll hear from my colleague, Jeff, next week. He's amazing. So you're lucky. Okay, give me a second. I'm trying to share my screen. All right. I hope you're all able to see it. And great. Feel free to interrupt me. I might not see the chat, so feel free to unmute yourself. Let me know if you need to say anything during this talk. I kept it very informal, and so I really appreciate dialogue, and I left time later for questions and conversation. So a little bit more about myself. I'm a professor at Whittier College. I teach in environmental science, but I spent the past 15, 20 years working with soil and biogeochemistry. So what I like to do, I like to get my hands dirty and I look at how soil functions and how especially soil organic matter and carbon cycle through soil. And I like to look at soils in the context of climate change and also how they play a role in keeping our ecosystems healthy and functioning well for all of us who take advantage of it. And let me know if you cannot see the scrolling of the slides. Should work. So in this talk, I will describe a little bit why soil in the context of sustainability. We'll look a little bit about what soil is made of. And then considering the interest of this group, I selected a couple of topics that hopefully you'll find interesting. Obviously, if you get me started about soil, will never end. So I had to kind of control myself and decide what to talk about and what to skip. But I welcome conversation, so you can email me and meet for coffee and talk about soil. So I hope that, and I imagine that all of you here this evening have some experience with soil and got to appreciate it in one form or another. But if you need some good reasons to appreciate this soil resource that we have under our feet, I can give you 3 perfectly good ones. Soil is a source and also a reservoir of nutrients and organic matter. And because of these, soil supports plant life. In addition, soil has the enormous potential to store carbon, and that is a direct offset to climate change. So we'll touch on that later on. Before, I want to take a step back and just remind ourselves what soil is. I'm sure you all played with potty soil, or you have a garden where you grow veggies, right? So you got your hands dirty. So when you lift up a handful of soil, what you have in your hands really, for half of it is empty space, nothing. Because, and in fact, you probably appreciated the fact that soil is loose material, it falls apart, it's kind of granular. So about half of that material that you have in your hands is empty space that is occupied by air or water or a mix of the two. So after a heavy rain event like we had in the spring, or after you water your garden, it's possible that all the empty space, the pores in the soil, are occupied by water, but then the water drains and air comes back because it's needed by the plants. The other half or so is occupied primarily by minerals: sand, silt, clay, a mixture, different proportions of the 3. And only the smallest slice of this soil pie is what makes our soil alive. And it gives soil the definition of soil, and that is organic matter. If you don't have organic matter, you're really not talking about soil. So that's why when I hear people say, oh, the man put their footprint on the moon soil, that's really not soil. There's no organic matter. But anyway, this is me digressing. Let's learn a little bit about organic matter in case you haven't, talked about that concept. What is it? Well, it's a combination of dead and living stuff that's in the soil, regardless of where it comes from and how decomposed, how broken down it is. And it's really, if you think about it, when you get a bag of potty soil from the Home Depot or somewhere, the nursery, it's very dark, it's very black. That's because it's rich in organic matter. Organic matter gives this really dark, from dark chocolate to almost black color to our soils. But just to remind ourselves, the composition, lots of terminology in our discipline, the composition is simply a process. And it converts fresh material, like a freshly fallen leaf or a dead spider, into essential nutrients. It's really a physical and chemical breakdown. And these nutrients, we're talking about nitrogen, phosphorus, potassium, sulfur, you name it. And it's all stuff that's needed by plants. It's like their vitamin pill, right? To be healthy and produce more biomass. And then about half of the organic matter that enters the soil that gives this nice dark chocolate color is actually carbon. And so that links with what we'll discuss later about soil have been a big reservoir of carbon in our under our feet. Who's decomposing all of this good stuff? Well, microbes. They're always at work. We don't see them. They're so small that we would need a microscope, or sometimes you need to extract the genetic material to see them, to recognize them. They operate this decomposition process. So a healthy soil is a soil that has a lot of material getting in, a healthy microbial community that breaks it down and returns it to the plants, and so the cycle continues. And speaking of cycle, that's why we frequently represent how nutrients go from plants to litter to the soil and some back up. It's really through a cycle, like arrows going through. So before humans were even on this planet, terrestrial systems functioned this way. Plants had enough material, enough nutrients to survive, to flourish, without any fertilizers, chemical fertilizer coming in bags, right? So the chemical fertilizer needs is a new need dictated by human beings to supplement what they take out through harvest from our crop systems. In fact, we don't fertilize forests, right? We don't fertilize a wetland out there. We also don't fertilize the grasslands in North Dakota. So that's why. And yet soils look so different one from the other. On the right, I wanted to put my favorite soil. It belongs to the spodosols. Don't worry about the names. This is a soil that you might find like in northern Michigan, for example, northern Minnesota, a soil that is covered by snow for many months during the year, and then the rain washes out a lot of things from nutrients to clay to organic matter and leaves this, dull color, gray minerals exposed. Very acidic soil, pH of 3, sometimes 4, and it supports a very vibrant vegetation, actually, conifers, birch trees, and so on. On the other side, we have a beautiful grassland soil with a lot of fine roots. You see how deeply they go, and it's very dark. So, dark soil means a lot of organic matter, and it develops under a grassland. Let's imagine like South Dakota, for example, Kansas, something like that. Yet, both soils formed under pressure from 5 factors, the same ones. They form every soil. Parent material, which is the rock every soil comes from, but it might be different from one location to another. Climate, we might find a different climate where this grassland is located compared to this gray soil. Topography, whether it's a depressional area where water gets stagnant or it's on a steep slope. Organisms, including plants, they can really determine what the soil looks like. Look at the one to the left. These deep roots continuously die and form. So they leave behind a lot of material that makes this soil so beautiful, perfect for agriculture, really healthy and rich. And their time. A young soil is a soil like the one to the right, maybe 15,000, 18,000 years old. So relatively speaking, young, right? So this is something to understand, that all soils come from the same originating factors. They just exert different pressure depending on location and on a lot of other environmental reasons. But the important thing here is that how long does it take for 1 centimeter, which is about half an inch of soil, to form? Do you have any idea? You can unmute yourself. You can write it in the chat. Any thoughts? I'll check the chat though to see. Anything? 500? Maggie? Anyone in accordance or disagreeing? 10 years, 50 years, 15, 10,000? Yeah, so Maggie's correct, actually. We have a soil scientist here in the room. It's between 500 and 1,000 years. So a long, long, long time. So what that means is that if we destroy because maybe we remove it, or we deplete it, or we contaminate it, 1 inch of soil, for sure, we are not going to see that soil regenerate. And so we will not see it our kids or our grandkids, right? So what that tells us is that soil is a non-renewable resource, just like oil. But we would never think of soil if asked, mention a non-renewable resource. Yet it is essential to life, not just human life, but life on the planet. And it's present in nearly all ecosystems, from the boreal forest up in Siberia or Alaska to the tropical forest. And soil productivity is also important because it supports plant life that is relevant for crop production. If that's not enough to understand why we should care so much about soil, I really invite you to watch then on your own, we don't have time now, a TED Talk by Nick Jelinski, who's a friend and colleague of mine from the University of Minnesota. And he really offers some really good insights, especially on how soil unites human beings. And there's one example that I want to share with you from this talk that Nick presents. Like when we hear our heartbeat in our chest, like we hear the ton, like 70 beats per minute or whatever that is, we're hearing something, a process that happens in our body that is actually made possible in part by the presence of potassium in our system. But yeah, that potassium maybe was in the banana that I ate 2 days ago. But then the banana took that potassium from the soil in Costa Rica where it was produced. And that soil maybe got that potassium from the cycling of nutrients from the vegetation that is there, or that was there thousands of years before, or maybe from the rock that decomposed. So just to understand that, as another soil scientist, I forget his name right now, says, is that human beings are just temporary, not soil. So we all derive from the soil resources. So you can agree or disagree with that, but I find it intriguing. What's really important to understand and to remember is that about 20% of the human population rely on soil resources for agricultural production. And for some areas of the world, farming is the major economical driver. So having poor soil, depleting our soil, can actually compromise economic stability of certain countries or certain regions. And that can create social inequalities, environmental injustice, political instability, you name it. And we have some clear examples from the war in Ukraine, if you think about it, and the failed deal for grain export to African countries, and how everything is sort of related, and how crop production can affect well-being of entire nations. And something to keep in mind is that most of the nutrients that plants need come from the soil. Plants only take very limited resources from the atmosphere. And so we need to maintain healthy soils because of that, to have good crops, not just abundant crops, but also healthy crops. And then we'll go back to carbon. So carbon is in the atmosphere. It contributes to climate change. We keep hearing about it, right, these days with the bad weather in the Northeast, and then the heat that we have, I mean, in the remaining half of the United States, but also in Europe, where I come from. It's unbearable right now. So that is in part due to high concentration of CO2 in the atmosphere. But trees can take up some of this CO2 because they need it to photosynthesize, to create new leaves, branches, roots, and so on. So that's one of the elements as cycles, like the other ones that I mentioned earlier, like nitrogen, phosphorus, potassium. So having healthy soil systems allow for this carbon to actually being broken down from the plant material by microbes. And it's true that microbes breathe CO2 out, so they send it back out in the atmosphere, but they also leave a lot of carbon behind. And I studied some soils from temperate forests in the US, and there was one portion, one small fraction of one soil that I was analyzing that had carbon that was 5,000 years old. So we radiocarbon dated it. And then there was another larger pool of carbon in the similar soils that were hundreds of years old. So when I talk about sending carbon in the soil, I'm really talking about long-term storage. A tree might live 100 years, 150 years. It might burn, as we know very well in this area. But soil, once carbon is there, we have a good chance that we can keep it there for a really long time. This is an example when you have a healthy forest. The carbon that is taken up by the forest is sometimes equal or even greater than what the forest lets out. But as soon as we start disturbing the forest by cutting, by degrading, by allowing invasive species to get in, the arrow out is way bigger than the arrow in, meaning that this forest becomes a contributor to climate change, to CO2 that accumulates in the atmosphere. So that's why we need to preserve our forest, in part, one of the many, many reasons. Unfortunately, degraded soils are everywhere. Look at Europe, look at the United States, look at South America. There are very few soils where agriculture is present that are not heavily degraded. So that means that we are losing valuable resources every day. This is an example, just because sometimes examples are, they can be visualized, they're more impactful. These are two soils taken from similar area. The one to the left is a pasture with rotational grazing. What that means is that animals like sheep or cows or goats are allowed in a specific area. They can graze, but not too much. They don't take everything out. And then they're moved on to another area so that the vegetation is allowed to grow back again. And the soil to the right, on the other hand, doesn't have any grazing. And it is conventional grain production, meaning that there's tillage, fertilizer application, and so on. So I don't need to tell you that they look different, right? Very different. The one to the left is darker, but you remember that the darker color means there's more organic matter. And if there's more organic matter, there's more carbon in it. And if there is more carbon, there are also more nutrients. So these are questions we could ask ourselves, but I'm actually answering to my own questions, as I frequently do. So what you see also, there are roots throughout on the left side, meaning the roots can penetrate easily in this soil, but the other one, the one to the right, is more compacted. Roots have a harder time to get in, but also water. And sometimes in areas that are prone to flooding, we see soils that have been very compacted, they've been neglected, and water doesn't penetrate easily but runs off. So healthy soils with a lot of carbon and nutrients are not just good for plants, but are also good for human safety, if we think about it, because they help storing water below ground, prevent erosion, prevent flooding, and so on. So management can do a whole lot to help us in maintaining ecosystem well-being. An example of how much carbon we have below ground, these are various ecosystems worldwide. And the half moon, the darker one below, the lower one represents soil carbon, and the top half represents the carbon that's stored above ground. So you see that almost everywhere, excluding just tropical forests, there's way more carbon below ground than above. So we really should pay a lot of attention to it. We tend to only value what we see. So we value trees, right? We value rivers, but we neglect soil, or we even look down at it simply because we don't understand it, we don't appreciate it. The other problem here is that wetlands and boreal forests, which are the two systems that contain the most soil carbon, are also the two ecosystems that are being destroyed at the fastest rate. One would think about tropical forests, but in reality, boreal forests are being compromised a lot by climate change in particular. Same for wetlands, but it's also human activity. Deforestation, or for wetlands, we've been draining wetlands for hundreds of years. And yet they really have an enormous importance when it comes to sequestering carbon, but also when we have wetlands like close to the ocean or close to rivers, they also prevent pollutants from getting into the water. They also contain the power of the waves, so they prevent erosion, coastal erosion. So they have a lot of excellent ecosystem services. Yes, yet we're losing these systems at a really fast rate. And losing all this carbon, it means we don't just lose it somewhere, it goes into the atmosphere. It becomes more carbon that accumulates in the atmosphere. It contributes to global warming. It contributes to these extreme events that we see every year now, pretty much. So preserving these systems is really, really important. So there are challenges. So every time there are challenges, there are opportunities. I like to see it that way. So we need to keep the carbon that is in the soil right there. Don't let it go anywhere. But then we also need to do a good job at adding carbon to the soil. So through regenerative practices, cover crops, increasing biodiversity. This can be done anywhere, even in cities. in urban settings. But to do that, we need to support farmers, first of all, reward them for doing this type of job, understand best practices, but also we need to have good policies, right, that support this type of activities, that reward them. And here's an example. I chose this one just because it talks about California. There are estimates that are being tossed around, right? And here, this one says that the average carbon footprint of one of us is 9.3 about metric tons of CO2 per year. But then they were also estimating that if agricultural producers in California were able to apply regenerative practices, decline their carbon footprint, they would actually offset the carbon footprint of about 40,000 people in California. So what they were trying to say with this message, with these numbers here, is that farmers and ranchers in our state and everywhere really are part of the climate change solutions. And this is important because normally we look at agriculture as the culprit, like there's nothing we can do, it's just bad. It can be good. We can still produce food, but also preserve the carbon and maybe send more carbon below ground. And I'm not going to go much longer. I want to have a chance to talk with you. So, but broader implications of why should we care? What's the big deal about soil carbon? Well, first of all, it helps cut greenhouse gas concentration in the air. We all should care about it. It's not the only tool. It's one of the many tools that we have, right, at our disposal to offset climate change. But also it improves quality in many ways. It gives soil structure. So that means their roots have a better matrix to grow in. It helps storing water, which is extremely important in the Southwest of the United States. It allows for more nutrients in the soil. So that means that we need less fertilizer. Fertilizer requires a lot of fossil fuel to be produced. So the less fertilizer we use, the less we contribute to fossil fuel combustion. And it also allows for healthy plants. And if properly managed, the land can really help us bridge the gap between those who don't have healthy, nutritious food every day and those who have maybe too much. And so we need to promote management that support this type of practices. Probably this group has seen the UN Sustainable Development Goals, or you're familiar with them. That's why I wanted to include them in here. These are 17 goals that the United Nations put forth as necessary to maintain sustainability worldwide. And carbon sequestration and healthy soils help us support many of these. Think about zero hunger, closing the poverty gap, having clean water. As I mentioned, healthy soils allow for water filtration, and so on. There are many more. There's actually a study that I'm happy to share with you all later if this is interesting to you, published in 2019, where actually Smith and his colleagues look at soil carbon sequestration, and the one which is at the center of this very complicated wheel. And they look at how it supports a number of soil functions, and it describes it. But then it goes further as you move away from the center of this wheel, and it connects how improving soil carbon in sequestration helps support many of the sustainable development goals. It's too much to go into the details here. I just wanted to mention these, but I'm happy to share the paper if you'd like that. So to close it, I really think that environmental stewardship starts at home. And I'm not just saying that we should all be out there digging our backyard and try to sequester more carbon. Sure, if you have the ability to do that, please. But it's also a matter of like advocating for environmental stewardship, or if you're in policymaking, support policies that are sound when it comes to the environment, or provide your support in many different ways, right? Also, every time we shop in the store, we make a statement, and so we have a great power in our hands. And also when we go to when we vote, right, we also can make big decisions there. In terms of soil and soil science, I really think that we need to position soil science in the context of broad ecological and societal changes. And really, we need to build this understanding that all of us have a moral obligation to care for our soils. So only if we do that, we'll build a generation that actually makes concerted effort to supply soil resources and to really appreciate the value of our soil, because our generation and the generation before us sometimes look down at soil and like we call it dirt, right? And that's problematic. So I'm going to close it here because that way we have more time to talk and go back and forth. I hope it's okay, but I'm happy to develop more around these concepts. And I don't know if I should stop sharing. You let me know what you would like me to do. Okay, now I can see the chat. Let me just see, sorry. Oh, this is a good question. So what is the difference between soil that takes 500 to 1,000 years from what we compost? And that's a great sign. Composting is a great thing. I do it too. It's amazing. When we compost, we're really creating mostly organic material. It's mostly organic matter that then we mix with the soil. And so it's a very fast process. And sometimes we even use microbial kind of cocktails that you can buy in a bag to really spur the activity, right? To really accelerate it. And if you use vermicompost, that's even faster, right? Because those little red wigglers, they do an amazing job at chewing up everything, including cardboard. And so that is mostly the buildup of organic matter in an accelerated way. So we are mimicking nature pretty much. So when we have our composting bin or the vermicompost, what we do, we are mimicking what nature does in a more spread out way and in a more diffuse way, if you will. In fact, with the compost, what we do, we mix it with our soil in our backyard, usually in our garden, to add it to the minerals that are in there. The soil that forms in a long time really results from the breakdown of rocks. And rocks have a lot of, depending on where you are, rocks are very different one from the other, but they might have a lot of potassium in them, there's silicon and all that, and it gets released. But as you can imagine, a rock takes a long time to break down, right? It does it though, it's been happening for millions of years. So that's a major difference that I see, just to answer to that question. Then there's another, if it's okay if I go down the questions, just let me know and interrupt me anytime. Farmers who practice soil conservation. Yeah, there are a lot of farmers that are very active and involved in staying more like attuned with the cycle of nature. This is like the old way of farming, right? That in extensive or intensive agriculture, what's called conventional, we kind of lost it a little bit simply because we have entire fields just with carrots or just with corn, with whatever, right? That is. And but now there are a lot of farmers, including here in California, who really go beyond being organic, because doing organic production is obviously important, but applying soil conservation means more than that. Applying soil conservation means that we really pay attention to the microbial mix that is in the soil, because there's an understanding that that is essential to the cycling of nutrients, as I was mentioning before. These farmers, typically, they tend to have a more biodynamic system, meaning that they might have more crops in the same plot of land. Like sometimes they have like an understory, it can be a cover crop, or it can be like a legume, a type of legume. And then they have another species that grows above, or they have successional farming, meaning that they play with season. And in California, we're lucky that the weather is good year round pretty much to cultivate. Up in Maine, obviously the story is a bit different, but it can be done anywhere really. And they also incorporate like straw material, or they have compost. So they have this understanding of biodynamic systems. And some of them even have hens and chickens like roaming around, because they also can pick on parasites. When we have chickens roaming in our garden. Not only they keep, unwanted grass at bay, but they also pick on unwanted pests. And so they keep really the system in check. So soil conservation among farmers is growing. It's really an important thing that's happening. And I'm happy every time I see that it's gaining ground, and there are really important farmers. Like I know of avocado growers, they're doing an amazing job right now in the area. But also smaller farmers. But at the end of the day, intensive farming is still there, and it's probably going to be there for a long time, because we still go to the store and we want eggplant in January. It's off season, even in California, right? And we still want a perfect apple or the perfect carrot. And if you have a garden, you know that perfect carrot almost doesn't exist, right? I mean, not in my garden. They always look so funky, and but they're equally good, right? So I think it's our fault a little bit as well, and understanding that we need to shop differently probably is very important to support these farmers, especially.
So related to that, I'm wondering, when we go to the grocery store, are there things we can be looking for to make less bad choices? Maybe the ideal would be to know a particular farmer that has really great practices and get all of your produce from them, talk to them at the farmer's market every week. But when we find ourselves at the grocery store, one of the things that we have, one of the ways we can influence is in our choices and what we buy. Are there things we can look for? Does the organic label mean anything there? Does free range? Are there other signs we can keep an eye out for to help us make decisions about what to be buying?
Yeah, that's a great question. And oh man, it's tough. Yeah, because we don't have clear signs, right? Beyond organic, and we all know it can be complicated as well, right? I tend to buy organic, especially when it comes to leafy greens or berries, or peaches, right? I don't necessarily buy organic when it comes to avocados or bananas or pineapples, because I know it's less of a problem. I also have a lot of cancer going through my family, and I wonder, sometimes I stop and wonder, is it environmental, right? I mean, why is there such a high incidence? Or there's also a lot of inflammation, this inflammatory disease that unfortunately I suffer from as well. And that's why I pay a lot of attention to the food. I also live in an apartment. I cannot grow my own food, right? And I know there are many other Californians in the same situation. So I think that when it comes especially to soil practices, we learn nothing from the supermarket. I think about that a lot, obviously. We know very little. We hope that when we buy organic carrots, celery, I advise to buy organic when it comes to these type of vegetables. We hope that the practice is followed and there are less harmful chemicals in there, but we don't have really a good way to know, sadly. Yeah. And but I stop in the in the supermarket and I think about it. I think about it tells me nothing about our soil at all. And if you go to the farmer's market, or if you know a grower like maybe nearby that you can go and talk to them, then you can engage in conversation and then you can learn much more. But it takes effort, and it shouldn't be that way. It shouldn't be on the consumer's shoulders, right, to bear this responsibility. And that's something that always bugs me from the plastic containers that then we need to dispose of. But there's no good recycling system. So why is it on me, right? But the same thing, why is organic food so expensive also? And that's social injustice once again. And I get it why some people need to buy their food in places where it's very cheap, but sacrificing perhaps traceability or the health side of things. But I don't blame them, because some families don't have a choice. And it shouldn't be that way. So sadly, yeah, I wish I had a more positive answer, but I share the concern. I really do.
And so then maybe flipping from the consumer side to the policy side, are there efforts out there that we could support? Are there, is anyone trying to make it easier for consumers to be informed or to push for changes in regulations that would affect industry practices on a larger scale, or anything along those lines that we could be involved in?
Yeah, like there are a lot of groups that are doing really good work, and some are really influencing policy as well, and that is really encouraging. Like the Organic Farmer Association is very active, and also it's pretty good that organizations are communicating with the community, even though it's very focused on supporting growers, right? Supporting farmers, as they should. But also like the Project Drawdown, I believe it's a nonprofit, and they're really trying to influence also policy. They move beyond just agriculture. They're more, holistic in their approach, but they're really focused on soil health and whatever that involves. And also the state of California, through the Healthy Soils Initiative, they also issued grants for growers, and that's been quite beneficial. They also supported over the years like experimental plots, just to see what works and what doesn't, because farmers sometimes are, working on a limited budget, especially small growers. And it's hard to tell them, why don't you try something new? And they feel like, well, I wish, but I don't have the financial ability to do it, right? Not everybody is well positioned. So there are groups. I don't know how much of that trickles down into the supermarket. And even when you go to places like Sprouts, for example, that, Sprouts itself for, being more connected to the growers, I don't see much of that when it comes to the produce aisle. There's not a whole lot. When you talk with marketers these days, they tell you, oh, new consumers, they want to hear a story. They want the story. Well, where's the story when we go to those supermarkets, right? Stories about, hey, these carrots come from, I think carrots, because I was just at the market earlier and I bought carrots, so that's why I keep going back to carrots. Or this celery, this is the farmer. I was just at a conference in April. It was focused on coffee, but there were also cocoa producers and so on. And many of them are very sensitive to the issue of climate change, losing their land, and they want to use sustainable practices. That area is very active in sustainability, everything pertaining to coffee, cocoa, and so on. But some of these cocoa producers had a QR code on their packaging to explain the story of the single farmer where the cocoa was produced and turned into this bar of chocolate. There was even the little cartoon portraying the grower. So it was really the storytelling that was so engaging, but it made you feel part of something bigger. And so I wish we had more of that among producers. Maybe something that maybe even a local group could ask. I know that there are some store managers that are a little bit more, they have a vision, they are more attuned. So I think it would be really amazing to be able to see that.
All right. Open up. There are folks who haven't had a chance to speak yet who'd like to ask a question. Please go ahead and use either the raise hand feature or in Zoom, or if you want to just raise your hand on camera, that's also totally fine. And maybe I'll ask Khan, do we have any questions in the chat that we've missed so far?
I don't know if you see this one. It's from Kira. And it says, do you consider, I'm sorry, I don't know how to pronounce this word, hugelkultur, to be appropriate technique to employ in our climate?
Oh, I see it now. Thank you. I'm not sure I know the word. Maybe it's just the terminology that's not familiar to me. Would you mind just explaining it a little bit? or is the burial of like straws and wood. I'm not super familiar with it, but I know that it's been used. I mean, conceptually, if you think about it, by burying carbon-rich material like straw, wood, right? And what you're doing, you're trying to make it decompose, and exactly in planting beds, sometimes you see these beds that create like a dome or something like that, right? If I'm not mistaken. I didn't know it was called that way, sorry. And so in a way, what you are doing, you are allowing for the slow breakdown of these materials. So you're sort of mimicking what happens in a compost, but you're using more recalcitrant material. So in a way, there's some carbon that leaves the system, obviously, because every time there is decomposition and material is broken down, microbes need to breathe out, because most of the microbes that are efficient at decomposing, they are like us, they need oxygen, right? But I think it is a very good strategy, one of the many really good strategies to send more carbon into the soil long term. Yeah, when possible, I don't think it's a bad idea. It's used quite a bit in very biodynamic systems, because sometimes the burial of these wood or straws, or depending on what one has at hand, sometimes cardboard is mixed in there. So this low decomposing material, right, is also mixed with more fresh material, and then water is applied because microbes need moisture. If it's too dry, in fact, your compost bin, if it's too dry, it fails, right? And so yeah, it's definitely a good strategy, something that we can do in our backyard. Something that is being done also abroad, like in India, for example. It's there are some groups that are really introducing that in their fields. Oh, there's a raised hand. Michelle, yes. Oh, you're on mute. Sorry, you need to unmute.
Okay. Yes, I'm wondering if you can talk a little bit about no-dig gardening, and if that's a good solution to building soil in our personal gardens.
Yeah, thank you for the question. Yeah, there's this thought, right, that avoiding digging helps keeping carbon pretty much in the soil and avoiding the loss of precious material. I think this is not that big of a problem in our gardens, where we just grow our veggies for personal consumption. But I heard about that. I heard people saying, oh, we shouldn't dig. But we do very mild tillage, in my opinion, when we're just by hand, we're just turning over the soil to mix it a little bit. I don't think it's that big of an issue in our plots. It becomes an issue, and that's where really there's been some strong voice out there in large fields, and it's been applied to the tillage. So tillage, when you go with machineries and you rotate the soil for about like 20 centimeter, like a foot or foot and a half, how deep the blade goes, right? That has been studied to actually disturb the soil and potentially release more carbon into the atmosphere, carbon that otherwise, if it could stay there, would be stored, like I mentioned earlier, for maybe hundreds of years. And in our soil, I think we disturb so little. And typically, if we are mindful gardeners, we add compost, maybe we cover in between seasons. So I don't think it creates that much damage.
I'm thinking that I understand what you're saying, because we're dealing with small areas of land in our yards, but I think could be game changer as far as if you're dealing with a lot of weeds and you need to get rid of the weeds. If you can cover that, kill them off with solarization and then just build on top of that, that's a way to get rid of the weeds and preserve the soil.
Yeah, that's a great way. Oh, sorry to interrupt you.
Yeah, without using herbicides.
Oh, totally. I solarized a few years ago, like 1/8 of an acre on campus at Whittier College, because then we planted coffee plants. And before that, there was just grass and weeds and all that. And obviously I didn't want to apply any herbicide. And so that's what I did. I actually applied vermicompost and steer manure. And then I covered with plastic, and the plastic that was not allowed to fly, right? I put sandbags to keep it down, and I left it there for like 6 months, maybe 7. And for 2 years, I didn't have weeds at all. And I didn't need, then we did a little bit of light tilling, but just to make sure that the vermicompost and the steer manure were well incorporated into our soil. And even today, like 3 years later, no, almost 4 years later, actually, we have a very rich organic rich soil under our coffee, and I apply very little fertilizer. We have some grass that's coming back, but it's not problematic right now. It's not as bad. So yeah, the solarization, like you describe it, I think it's really the way to go. If one has the patience, right, to let it sit, and it doesn't look pretty for a while, but especially if one adds steer manure, vermicompost, and all these very, nutrient-rich materials, you find yourself with a beautiful soil to grow whatever you want to grow later in there. Yes.
Okay, you gave me a good idea about the sandbags. I'm getting ready to do solarization, so I'm wondering how to hold it all down. Sandbags is a good idea.
Yeah, or even if you have like 2x4s, right, that they keep really the plastic, like the tarp, whatever you use down. The key is to not let too much air in. Because if the air comes in, well, microbes are in there, they decompose, and also these, nutsedge especially, my goodness, it grows everywhere. It's so stubborn. And so really the key is to keep the air out as much as possible, so it suffocates pretty much those roots. Yeah, so yeah, 2x4, anything, or if you have tiles that you don't use, like you left over in the garage or something, that stuff is all good, but make sure there's an entry point for air, so all around the perimeter and then in the middle here and there. That worked for me, at least.
Okay, thank you.
I haven't checked the chat. Oh, in dry soils, we are going back to the burial of the, straws or wood. Yeah, the idea is also it contains moisture. And so in our dry climate is a really big deal, right? Because anything that you can do to keep the moisture in the soil, and we all know we need to water early in the morning, late in the evening, where evaporation is minimal. But then if the soil is not covered, maybe I'm not a big fan of mulch, but that's more personal, I think. It's widely used. But even leaves, if you have just an orchard, right, with trees, anything you can do to really keep the moisture down. But what I did, I mentioned my coffee plants, and you're welcome to visit anytime somebody is, you want to take a trip to Whittier, come to my coffee orchard. I'm eager to show it to everybody. I put a bunch of California natives as understory. I have probably 100 plants under 64 coffee trees, and not only they are beautiful, they attract pollinators, but they also replace nutsedge and all other things that I don't want. And at the same time, they cover the ground, and so, and because I water very little my plants, and the moisture tends to stick around a little bit, so that's another thing to consider. Oh, see, I see a comment about solarization. Yeah, if you have extra soil, you want to put it on the tarp. That also keeps it down. That works great. And it's true. I had the same issue. I see a comment from Rachel that, yeah, the grass is so stubborn. It came back for me as well in the corners, in the areas like around the perimeter. I have students, they're cheap labor, and so I send them out to hand weed. They didn't like it at all, but it works really well. But yeah, it's the corners and the borders are the tricky parts where it's really hard to get rid of it. Oh, the compost, I can, the mulch, sorry, the mulch. Yeah, I mean, I think we went overboard with mulch and putting it everywhere because ultimately it's very recalcitrant material. And I'm not a particular fan for the one that you buy that has color in it, or they have some sort of preservatives, right? So the mulch doesn't change color with time, which is a natural process, by the way. And sometimes these are chemicals, you know, they sell them like in black, in red. They're beautiful. They look really nice, but I don't particularly like it, but cosmetically, of course, they serve a purpose and people think it's natural material. At a minimum, I would buy from certified vendors and maybe avoid the chemically colored ones. But I think we went overboard with putting it everywhere, but it's an acidifying element. There are studies out there. I need to document myself a bit more actually on that as well, about mulch not being always the perfect one. Plus it decomposes. If it's somewhere that it's not really needed, why would you have something that releases CO2 back in the atmosphere? But again, a lot of people would argue with me with very good good reasons. So it's just one view.
We have a question from Sorrel asking about an elevator pitch that we could all take away from here to engage folks who haven't gotten to hear a whole presentation like this.
Yeah, thank you. That's tough. So I think something that my work is to remind people that economic stability derives from soil, healthy soils, because a lot of people lost track really of where food comes from, and also they lost track with the fact that a lot of countries and nations don't apply irrigation, don't apply fertilizers, right? They live with what they got, and it's very different than industrialized countries. So yeah, what I would say, I think one point that typically is quite catchy is the idea that soil is a non-renewable resource. So comparing it to oil, and that is the product of thousands of years, and that is a living thing, living with microbes that allow for ecosystem services, for plant growth. So the soil serves more of a purpose than just growing food, because there are a lot of people in industrialized countries that look down at the food production, like, oh, you can grow hydroponically, which, you know, it's partly true. So yeah, I would, to me, a selling point is really to put soil in the context of what it does. So it's a non-renewable resource that does much more than just supporting plants that then we eat, but it controls for flooding. It's a tool to combat climate change, and it promotes and supports biodiversity. So there are many functions to healthy soils, and that's why we should nurture it and care for it. So that would be my thought.
We have time for a quick question. If anybody has been holding off, this is last call, last chance to get your question in. But can you recommend a landscaper? Question.
Oh, I don't know. I do my own landscaping on campus. I don't know. When you hire a landscaper, I think it's good to interview them and ask a little bit what they think and what they know, because some, it's not their fault, but they are asked by like big associations or golf courses, just make things look pretty, and they don't even think. So I would probably interview them. There's Sequoia Landscaping that does a lot of good job in Southern California. It's a big company. I know the owner directly. And he's quite knowledgeable about the value of native plants and the value of pollinators and all of that. And I think that if engaged by the right consumer, I think he would play a good role. Like, he knows what to do. But then, of course, there's, you know, the golf resort or the resort or the golf course, they ask him to do certain things, but he's quite good. Mm-hmm. Oh, Natural Earth, I don't know. Okay, good to know. I'm curious about it. Yeah, I think I would probably interview them. I would just ask questions, and and see how much they know about biodiversity, the importance of native species, soil building. I think it's fair to ask these questions to our landscapers.
Well, thank you so much, Dr. Fissore, for taking time to share all of your knowledge with us. And thank you to all of you who are able to join us. We hope you'll be able to come back again, same time next Monday, to talk with us about water policy. And Han has put a link in the chat to our resource guide. So if you're looking for more resources from Sustainable Claremont, please be sure to check that out. Thank you all. Have a great night.
So much. Thank you.
Thank you.